In this video, let's explore the concepts of horizontal and vertical scaling. We'll discuss what these strategies entail and the various trade-offs associated with each. Scaling refers to the ability of a system to handle increased load by adding more resources. As the demand or load on a system increases, scaling allows it to maintain performance and availability. This can be achieved by adding more servers or upgrading the hardware of existing servers. Vertical scaling, also known as scaling up, involves adding more power to an existing machine. This can be achieved by upgrading components like the central processing unit, random access memory, or storage. For example, upgrading a server from 4 cores and 8 GB of RAM to 8 cores and 16 GB of RAM is an example of vertical scaling. Vertical scaling enhances the capabilities of a single server to handle increased workloads. Horizontal scaling, also known as scaling out, involves adding more machines to the pool of resources. Instead of upgrading a single server, multiple servers are added to distribute the workload. For example, instead of one server with 4 cores and 8 GB of RAM, the system expands to 3 servers each with 4 cores and 8 GB of RAM. This distributes the load across multiple machines, enhancing the system's capacity and resilience. Let's discuss the trade-offs of vertical scaling. On the pro side, vertical scaling offers simple implementation, as it typically involves upgrading existing hardware components. It doesn't require major architectural changes to the application or system. And it also maintains data consistency because all operations still occur on a single machine. On the con side, vertical scaling is limited by hardware constraints. There is a limit to how much you can upgrade a single machine. It also creates a single point of failure. If the upgraded server fails, the entire application may go down. Furthermore, it can become expensive at scale as the cost of high-end hardware increases exponentially. Now let's discuss the trade-offs of horizontal scaling. On the pro side, horizontal scaling offers high fault tolerance because if one machine fails, the other machines can continue to operate. Also, horizontal scaling allows for theoretically unlimited scaling by simply adding more machines to the pool. Additionally, it can be cost-effective for long-term growth, especially when using commodity hardware. On the con side, horizontal scaling introduces architectural complexity, as the application needs to be designed to distribute workloads across multiple machines. It also presents data consistency challenges, requiring careful management of distributed data. Furthermore, it introduces network overhead as data needs to be transferred between multiple machines. Let's explore when to choose vertical versus horizontal scaling. Choose vertical scaling for simple applications where the load is not expected to increase dramatically. Database workloads often benefit from vertical scaling. Increasing RAM and CPU can significantly improve performance. Vertical scaling is also suitable for quick performance boosts. If you need immediate improvements without significant architectural changes, this is the way to go. Also, if you have limited budget for redesign, vertical scaling is preferable. Choose horizontal scaling when high availability is required. Distributing the workload across multiple machines ensures that the application remains operational, even if one machine fails. Horizontal scaling is also suitable when massive scale is needed, enabling the system to handle a large number of users or requests. Choose horizontal scaling for distributed applications, designed to run across multiple machines. Lastly, if you have long-term growth plans, horizontal scaling is preferable. Let's summarize the key takeaways from this video. Both vertical and horizontal scaling strategies have distinct trade-offs. The choice depends on your specific requirements. When deciding between vertical and horizontal scaling, consider your constraints, goals, and future growth plans. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.